So what if I told you that one of the world's most ancient civilizations is literally sinking into the ground? Today we're going to dive into Iran's water crisis. It's a really powerful story about how a nation's most precious resource is disappearing and what that could mean for the rest of us.
Experts have a name for what's happening, and it's a stark one: water bankruptcy. Now, this isn't just your typical drought we're talking about. This is a full-blown crisis of supply and demand. So what on earth does it mean for an entire country to go bankrupt on water?
Okay, so think about it like a bank account. The rain and snow, those are your deposits. But your withdrawals for farms, for cities, for industry are way bigger than your deposits. If you do that year after year, you're living on borrowed time, right? You're draining your savings. Eventually, that account is just empty.
And you know, this isn't just some abstract metaphor. Let's take a look at the very real and very visible consequences of this water bankruptcy on the ground in Iran. It's like this devastating domino effect. It starts with the obvious stuff, right? Like drying lakes and rivers. But then, as you drain the underground water, the aquifers, the actual land starts to sink. Yeah, you heard me, it just collapses. That's called subsidence. And from there, the water quality gets worse, soil erodes, and you get these massive choking dust storms. These aren't just one-off problems. They're all connected, and they are affecting millions of people.
So the big question is, what's driving these massive withdrawals from the water bank? Well, climate change definitely plays a part, but the main culprit here is something researchers call an anthropogenic drought. It's a fancy term, but it just means a drought that's caused by us, by people.
Now, I know this chart shows data from Spain, but it's another dry region, and it tells a story that is all too familiar in Iran. Just look at that huge slice of the pie. It's no contest. Agriculture by far is the thirstiest sector out there, guzzling most of the fresh water.
And this number right here is everything. 0. In a key farming area in Iran, that's the official price for irrigation water. 0. Farmers just have to pay to pump it out of the ground. So think about it. When a resource is basically free, what's the incentive to save it? There isn't one.
Okay, so the situation sounds pretty bleak, I get it. But there is a glimmer of hope. There's a solution that's gaining a lot of traction all over the world, and it's all about turning our waste into a brand new source of water.
The concept is actually really simple. Instead of using water just once and then throwing it away, we can treat it and give it a whole second life. Now, we're not talking about turning sewage into your next glass of drinking water, but we are talking about creating a new, super reliable source for all the things that don't need water to be perfectly pristine.
So how do you actually turn waste back into water? Well, it's a multi-stage cleaning job. First, you collect it and get out all the big stuff. Then, you use helpful bacteria to get rid of the organic matter. But the real magic, the game changer, is that final step. That's where you use advanced filtration, even things like UV light, to purify the water to an incredibly high standard. It's totally safe to reuse.
And the possibilities here are huge. This reclaimed water can irrigate crops, cool down industrial machines, water our city parks and golf courses. You can even use it to start refilling those underground aquifers and begin reversing some of the damage. It's a total game changer.
So, reusing wastewater is a fantastic option, but it's not the only one. A lot of countries are looking at desalinization, taking the salt out of seawater. So with these big ideas on the table, how do we choose the path that's actually greenest?
And that is the key question for anyone making these decisions. To answer it properly, you have to measure the total environmental costs of every single option.
And to do that, scientists use a tool called a life cycle assessment, or LCA. I love this definition, an environmental report card. It's perfect. It looks at the whole shebang, from the energy you use to the waste you produce. It gives you that full cradle-to-grave picture of the impact.
So, when you put these two side by side using that report card, a very clear winner emerges. Desalination is an energy hog. It takes a ton of power, and it creates this toxic, super salty waste called brine. Wastewater reuse, on the other hand, uses way less energy, and it actually turns a waste product into something valuable. And the benefit for the climate is just huge. One study found that by switching from desalination to wastewater reuse, you can cut greenhouse gas emissions by a staggering 85%. That is a massive, massive difference.
Okay, so the technology is there, the environmental case is a slam dunk. But how do we actually make this happen in the real world? And that brings us to the final and maybe the most difficult piece of the puzzle, the economics and politics of water. If economics is part of what got us into this problem, then it has to be part of the solution. So how do you actually convince millions of people to start valuing water in a completely different way?
Well, it turns out that economic studies in Iran have shown that pricing is an incredibly powerful tool. It's just like this chart shows. When the price of water goes up, even just a little, farmers are suddenly motivated to use it more efficiently. Pricing water correctly sends a clear signal. This stuff is valuable, don't waste it.
But let's be real, pricing isn't a silver bullet. There are other major hurdles. Building these advanced treatment plants, that's expensive. You also need governments to create clear rules and regulations. And maybe the most important thing of all, you have to build public trust so people feel confident in the safety of reclaimed water. It's a really complex challenge.
And ultimately, that's what this all comes down to. Solving a water crisis like this, it's not just about a cool new technology. It requires a fundamental shift in our thinking. We have to move from this use it and dispose of it model to a circular one, where every single drop is valued and reused.
And that leaves us with one final question. As our world's population keeps growing and the climate keeps changing, water bankruptcy is a threat facing not just one nation, but many of us. So, is reusing our water just another option on the table, or is it an absolute necessity for our survival?